All right, ladies and gentlemen, here we are with some rate and rate out problems yet again. I think this should be easy at this point in your career now that you've been working with integrals for a couple of weeks. So I want to just do sort of a baby example and then a hard example here. So first we have our good old giving up on calculus and going to Six Flags context. And just sort of as a reminder, we're asked to say what g of t represents. And g of t, of course, is rate in minus rate out, which is then the rate of change of the total number of people in the park at time t. So if then I'm asked to find the number of people in the park at t equals 9, well, I'm given this initial value, I can be like 100 plus the integral from 0 to 9 of g of t dt, or I could write that as 100 plus the integral from 0 to 9 of e of t minus L of t. And I will show you how I would type this into my calculator. First I would type them into my grapher and remember which one is which. Essentially L is y2 here. And then I would just use my good old math 9 function. So I go math 9. Let's put it at 100 first, 100, and then math 9 from 0 to 9. And the way I can type it in is exactly how you'd think. I can go vars, and I can do, remember L was y2, so I want to do y1, and then minus, and that tells me there are 2017 people in the park. And usually on an AP style question, they would tell you to round to the nearest people. So I can just say people. I don't have to give the decimal in this case, probably. And that's it. So we can integrate these just like any other integral problem in context. We're going to try a spicier one. This is an old AP FRQ from like the 2000s. We've seen this stem before at this point, but not necessarily all of the questions. So we have an A, B, and C. I think we've done A before. How many cubic feet of snow have accumulated in the driveway? Take a second, pause and read it if you need to here, right? Well, it's helpful to know for this one that there is no snow at t0. So that would be just the integral from 0 to 6 of f of t. And I would integrate on the calculator. I'm actually just going to skip that because we've done that a bunch before. Integrate on calc, and then my units would be cubic feet of snow. Next, we're asked to find the rate of change of the volume of snow on the driveway at 8 a.m. So here, this is a little bit trickier because we have to now figure out what it's asking me for. The rate of change of the volume of the snow. So the rate of change, the volume of snow is the total, right? So really what this is asking us for in this case is the rate in minus the rate out. So in this case, I would want f of 8 minus g of 8. Because notice we have a rate modeled by and a rate modeled by for both of those. So f of 8 minus g of 8. Well, g of 8 is 108, right? We have a piecewise function here. 8's the last piece. F of 8 I would type in just like this, or you could do second calc value, but we're going to have to subtract 108 for it. So I just typed it straight in like this, and then we get here this value. So negative 59.8 to, 582. Okay, so that's my value. And we got that, of course, by being like 7 times 8 e to the cosine of 8 minus 108. My units, of course, it's a rate in cubic feet per hour. So that tells us that the volume of snow is decreasing. She's making some progress. Now, part C is the hardest part here. How many cubic feet of snow are on the driveway at 9 a.m.? Now, the reason this is hard is because of our guy g of t here, right? G of t is a piecewise function. That makes our job a little bit more challenging, right? So if I want 9 a.m., I need the total in minus the total out, right? So I would do the integral from 0 to 9 of f of t dt minus the integral of 0 to 9 of g of t. Or I could combine these, but I wrote it this way for a particular reason that we'll see in a second. Okay, so the way this will look, because we have this piecewise function, is I would be like, we'd have the integral from 0 to 9 of f of t dt minus the integral from 0 to 6 of 0 minus, you will see the pattern here quickly, I think, the integral from 6 to 7 of 125 minus the integral from 7 to 9 of 108. And I should really say dt after all of these. It's just part of the notation. dt. Okay, so notice where I got these. So here's my first bounds, here's my last bounds, and here's my middle bounds, right? So to integrate a piecewise function, we have to split that all up and integrate each piece separately. So to do this on your calculator, which is all we know how to do at the moment, this is going to be kind of tedious. So I can do just my integral from 0 to 9. I have f on y1. And then I just type it in exactly as I see it. So this integral is obviously 0, by the way, so you don't need to type that one in. But just for the sake of thoroughness. So that is my whole integral. We'll continue to work with these piecewise functions a little bit throughout the year. But it kind of makes sense, right? Because we'd have several different pieces we have to worry about, and these bounds are our x values. And it'll probably think pretty hard about this one. At 26.335 feet. And it's cubic feet, right? Cubic feet of snow. So that is a tougher rate in, rate out problem. But the logic is the same. It's just that piecewise function that makes it a little bit harder. You guys are going to cruise through this at this point, I think.